I welcome you all in this video. In this video, I'm going to talk about the important points to be considered before solving the numericals. So first point is calculation of permissible stresses. And in that, we will consider the permissible stresses first for rod, fork and eye. So if you look at this diagram, the rod and fork are not the different parts, as you know. The geometry is different, so that's why the name is given different. Similarly, on this side, this rod and eye, these are not the different parts, so just the geometry is different, that's why the name is given different. That means if the material of rod and fork is same, the permissible stresses that can be calculated for rod same can be used for fork. Similarly here, the permissible stresses calculated for rod can be used same for eye. That means the permissible stresses for rod and fork are same, the permissible stresses for rod and eye are same, but in most of the cases the material of both the rod is same, so therefore the permissible stresses for rod, fork and eye are always same. So we can write the permissible stresses are same. So permissible stresses for these three regions, rod, fork and eye, are always same. Now consider for pin. Now this is a pin in this knuckle joint, but the case is that if the rod and pin are made up of same material, if this rod and pin is made up of same material, then we can use the permissible stresses calculated for rod same for pin. So that means we can write, if the material of rod and pin is same, then the permissible stresses for rod and pin are also. That means we don't have to calculate different permissible stresses for rod and differently for pin if the material is same. Now consider the second case. If the rod and pin are made up of different material, if the material of rod is different and the material of pin is different, then the permissible stresses for a rod are different. So we have to calculate permissible stresses for rod differently, and we have to calculate permissible or allowable stresses for pin differently, and these two are not equal as the material is different. So as we know that these permissible stresses are dependent on the parameters like SYT and SOT. Like permissible tensile stress is given by SYT upon Fs for ductile material, and if the material is same for rod and pin, then that means SYT is same, and hence permissible stresses sigma T, permissible tensile stress, will also be same. But if the material is different, then SYT of rod will be different, SYT of pin will be different, and hence the different values of permissible stress like sigma T we can get. So different value of sigma T will get if the material of rod and pin is different. So likewise, the permissible shear stress will be different, permissible bending stress will be different, permissible compressive stress will be different if the material is different of rod and pin. But here, as the material of rod and pin is same, so the permissible tensile, permissible shear, permissible compressive and permissible bending stress can be same used for rod and pin. Now next point is, if SYC or permissible compressive stress sigma C is not given. Okay, so in that case we can take SYC is equal to SYT, or if the permissible tensile stress is given, then we can take permissible compressive stress sigma C is equal to permissible tensile stress. Okay, so this point is very important. Remember that if the SYC is not given, then we can take SYC equal to SYT, or if the permissible tensile stress is given, then if we can take permissible compressive stress equal to permissible tensile stress. But if the value of SYC is given, okay, if the value of SYC is given, then we have to use this given SYC to find out permissible compressive stress like SYC upon Fs. Okay, so remember this point. Similarly, if the permissible compressive stress directly given like 120 Newton per mm square, okay, then we have to use this given value of permissible compressive stress. In that case, maybe sigma C will be different and sigma T may be different. Like Permissible tensile stress may be either 120 per Newton per mm square, or sigma t may be different than this 120, like 100 Newton per mm square. So it is not always the case that sigma c and sigma t are same. So if sigma c is not given, we can take equal to sigma t, but if in the numerical sigma c is given, then we have to use the given value of sigma c, and this given sigma c may be equal to sigma t or may not be equal to sigma t. And last point is round of the dimensions. Now we know that while designing a knuckle joint or any other part, we can calculate the dimensions of parts, okay, different dimensions of part. So while calculating such dimensions, you may get these answers in fraction, like this diameter of pin you may get like this 32.52. so we have to round up this dimension, so we can make it this dimension either 32 mm or 33 mm. So generally you have to add 2 to 3 mm into that answer that you have calculated, but generally we try to keep the final rounded off answer in as a even number. Okay, we try to keep this rounded off value as a even number, and this is a odd number. Okay, so we used to keep the rounded off answer as a even number. Okay, but if you go for this odd number also, it is also correct, because examiner will check this your calculated answer. Okay, examiner will check this first, this calculated answer, and depending on your rounded off value, the further answers will change a little bit, but that will not affect that much, because examiner will consider this calculated answer of your dimensions, and he can understand that there may be some change because of this rounding up process, because here one student has added 2 mm and he has written the answer of D as a 32, and one student has added 3 mm, so answer of diameter of pin is 33 mm. So in this case both the answers are correct, because both the student definitely they have got this answer of diameter of pin as 32.52 mm, and then they have rounded off it as either 32 or 33. Okay, so this calculated answer must be same for in every case. Okay, so this rounded off value may be different depending on how much mm you have added into the original answer. You can add 2 mm or you can add 3 mm. Okay, so this is the case, and these are the points that you must know before solving the numericals.